Now, like bases are when they have the same variable. So number 5 would be when you use the quotient rule, and this is to subtract the exponents. So it's 19 minus 11. So you would just do n to the 8th. Have y'all learned this before?
Yeah.
Okay, good. Okay. And then this one is when you would multiply the exponents. So 4 times 3 is n to the 12th. And then what's the answer for number 7? H to the 17th. Good. Does anybody have any questions? All right, can we please get out our notebooks so that we can make sure we're skipping the same pages together so that we can put our... Does everybody have their notebook? For the love of Michael Bolton, children, just go to Walmart. I will give you $2. Those of us that do have our notebooks, are you ready to skip with me? Because we got to skip for our math workshop. So go to this page. Go to 39A. Alright, pick up 39A in your hand, and you flip it, and the back of that is 39B, and then you have 39C, correct? Flip again, you have 39D, that was week 3. So over here on the right, this is going to be 39E for week 4. I want to go ahead and label it so that we're leaving space. Blessings. Are we ready? Yes, no, maybe so. Thank you. Alright, on the back of that is going to be 39F. So then over here will be 39G. And this is week 5. Five, 4, 3, 2, 1. I'm flipping. The back of that is 39H. Over here is 39I, and this is week 6. Next year, I think I'm going to have math workshops in a separate folder. What do you think is going to go on the back of that? J. And over here is 39K. And that's week 7. And the back of that is 39L. And week 8. And we're going to stop there because we'll turn in week 9 or something. I'm tired of skipping pages. Alright, so then what that means is that the next page over here is going to be page 40A, and that's going to be where we start Unit 6. So your little half sheets that we cut in half and shared, and if anybody has an extra, I would greatly appreciate it because I need one. You're going to glue that down right here, and then we're going to make a tabby. I'm going to show you how to make those. So glue your Unit 6 sheet. That almost came out as something really bad. Table of contents. Did you all turn in your stained glass project? Okay, good. Thank you. Today is the 10th. Did any table have an extra of the unit table of contents? Oh, thank you. Alright, so Unit 6 is our ham sandwich. Is our unit on systems of equations. And we can solve systems different ways. We can solve it 3 different ways. We can graph. We can solve by substitution, which means we plug something in. And we can eliminate, which means we kill something. The first method that we're going to do is graphing, which is why I gave you that zombie sheet yesterday, in hopes that you would be able to figure it out, but I should have left more detailed instructions. I was just trying to get back out of here. Super sorry. So this is Unit 6. Page 41 is going to be Systems of Equations. And page 42 is going to be Graphing Systems. Are we ready? Alright, so we're going to leave the back of 40A blank. So on the back, we're going to leave it blank, and we're going to come over here to the right side. Systems of Equations is going to be 41A. So you can cut that out and glue it down. Solutions to Systems is going to be on 41B. So you can cut that out and glue it down. And then solving by graphing is going to be on page 42A. Good save. Alright, so our learning target for the whole unit is I can solve a system of equations. That's our goal. We're going to do it 3 different ways. Well, 4 once we... 3. But first we need to talk about what a system is. Now, since this is equations, that means it's going to be more than one equation. A system is 2 or more equations. That can have a solution. It's two or more equations that can have a solution. You can graph both equations, you can solve it by substitution, or you can eliminate. And we're going to graph. Now, a solution is a point or coordinate. A point or coordinate that lies on both lines. So if 1, 2 is a solution, it would have to be for both the top equation and for the bottom one. And it's where they cross when we're graphing. So now this is what a system looks like. It's two equations. It's in this fancy little bracket. It doesn't have a closed bracket. And then we graph both lines. So I'm going to start by graphing this one in pink. Now, it's in slope-intercept form, so the easiest thing to do is to graph it because it's in slope-intercept form. So what would we do first to graph this? We would go down 2. And then what would we do? Good, take a point. And I would go as many points as possible because you're never really sure where the lines are going to cross. And then we're going to graph our other one. Now you graph them on the same, you graph them on the same coordinate plane. So for this one, where would we start? Would we start at -2 or +7? Positive 7, because it's our y-intercept. 1, 2, 3, 4, 5, 6, 7. And then what do we do?
Down 2, right.
Good, take a point. Oh, look at that. They cross. Isn't it magic? No, they cross right here at that point. What is the coordinate for that point? 3, 1. Good. Take a point. And that's all you have to do. That's the solution to our system. If you plugged in 3, 1 into both of these, it would satisfy it. And we've solved our first system. And if this was on your worksheet from yesterday, a zombie would have been right there, and you could have killed it.
Yesterday I turned it into what equation?
No.
Did that mess stuff up?
Yes. But it's okay because you're going to be able to fix it for homework tonight. And after we practice, you'll understand more.
I remember doing this last year.
Okay. Alright, are we ready to go to the next page, or do we need a mo? We need a mo? Okay. And guys, my ears are stopped up from this cold, so I can't hear you more than I normally can't hear you. And I know y'all really like to whisper for some unknown reason, so please speak up just a little bit. Whitney, the ham sandwich are you doing? Put it away, Tater. Alright, solutions to systems. Now again, solutions are a point. So all this is asking you to do on the graphs is look at where the two lines cross and identify what that point is. Do you think you can do that? I hope so. Can anybody name that first point on the one on the left over here?
4, 9.
What, darling?
4, 9.
4, 9. Awesome. Good. Take a point. Can anybody else Someone else name the one on the right. Grant?
Oh, well, I was just gonna say that. Isn't the other one 4-8?
Yeah, is it 8?
1, 2, 3, 4, 5, 6, 7. It is 8. Good job, guys. Take a point.
I can do the other one too.
Okay.
It's 7-3. Or it's
Negative 7, 3. Good. Does anybody have any questions? It's easy peasy, right? Alright, now, what do you think it would look like on a table? If on a graph it's where they cross, what would it look like on a table? Yes, they have the exact same number. Good, take a point. So what would our solution be for this one on the left? Does anybody see where they have the same number?
Yes.
It's right here, right? So this is your x value, and these are your y values. So the coordinate is 2, negative 11. Isn't it magic? Alright, what about this one over here?
Negative 312.
Negative 312. Good, take a point. Elmer earned y'all a point.
I don't know.
It's right there. Alright, do you think you're ready to graph again? Let's do this. Turn the page to 42A. Alright, so there are 3 steps to graphing. It's crazy. The first thing you do is check and see if they are in slope-intercept form. So you want them to both look like y equals mx plus b because that's how we graph. Then we graph both equations on the same coordinate grid. And then we look for the point of intersection. Now, this one is already solved for us, right? The second one. So we need to solve the top one. So what we're going to do is we're going to bring it over here. It's going to travel. And we have 4y minus x equals 16. And we're going to solve that equation for y because we need to get in slope-intercept form. So somebody at Gryffindor, can you tell me what I should do first? Add x. Good. Take a point. Alright, and that gives me 4y equals x plus 16. Why did I not change it to 16x? Can I do that? Nope, because they are not like terms. Alright, what do I do now? Divide by 4. Do I divide all the things or one of the things? All the things. Alright, what's the number in front of x? 1. So that's going to be 1/4, right? Alright, and then what's 16 divided by 4?
4.
Awesome. Oh, is that the sun? What's that? Alright, so we have both of our equations in slope-intercept form. We're going to graph this one and this one. I'm going to graph this guy in my yellowish color. So to graph that, I would first go down 1. And then would I go up 3 right 2 or down 3 right 2?
Up 3.
Up 3. Good. Take a point. Bless you, because it's positive. Alright, now I need to graph this guy. So we go up 4. 1, 2, 3, 4. And then would I go up 1 and right 4 or down 1 and right 4?
Up 1, right 4.
Good. Take a point. Look at that, they cross. Isn't it magic? Now, the last step is to label your point. So, what's that point? 4 or 5. And that's it. Boom, you're done. Do we feel like we can tackle the zombies now? Alright, do you want to look at it together before we, like, break off on our own? Let's look at it. Let me go get my zombie sheet and we'll look at it together. Was anybody not here yesterday and need a zombie? Alright, it says to solve each system by any method, but I want us to graph. So that means that we need to get these in slope-intercept form. Do you think we should have a separate piece of paper out to work these out on?
Yes.
That'd probably help. Alright, so what I'm going to do with mine is I'm going to label this 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, you know what? Nope. Nope. We're not doing this. Yeah, because some of these, like, look at this one. Look at number 5. If you solve this for y, you're going to have to divide by 8, right?
Yep.
25 divided by 8 is like 3 point psycho. And then on...
I was confused because there was like a lot of fractions.
Yeah. Okay. So this is not the one that I thought it was going to be. Sad. Well, okay, taters. Super sorry about that. That makes me angry now. I don't have as fun of a worksheet for you to do now for your homework, but they're at least easy for you to graph. How about that? There you go. If you have not written on yours, can I have it back so we don't waste these and I can like use them later?
I only have numbers in this.
That's fine. Thank you. You'll just make a pile on the tower, that'd be great of these. Yeah, that's fine. Alright, so this one, it says to solve it by graphing. Now what it means to check algebraically is just to plug your point back in. I'm okay if you don't do that. Do you guys want to work any of them out together, or are you good? We think we're okay? Alright, get started. Did y'all get 2, 2? Awesome. No solution, because they are parallel lines. So far we've had one solution, we've had no solution. Do you think it's possible to have infinitely many solutions? What would that look like?
So, it'd be the same.
It'd be the same line, they're on top of each other? Awesome. Take a point.